Hello, I will talk about special relativity and the twin paradox. Special relativity is an explanation of how speed affects mass, time and space. As an object approaches the speed of light, the mass of the object becomes infinite, and so does the energy required to move it. This means that it is impossible for any matter to go faster the speed of light or even reach the speed of light. Now I will talk about the twin paradox. The first twin flies into space at a very high speed, for example 240,000 kilometers per second, and returns to Earth, while the second remains on Earth. According to the theory of special relativity, movement at high speed slows down the flow of time. So the brother who went on a journey in space will return to Earth 10 years younger than his brother who stayed on Earth. Now I will describe the paradox in detail. One twin remains on Earth while his brother moves away in a spaceship at very high speed, close to the speed of light. At some point, the brother turns around and returns to Earth. According to the theory of relativity, the journey in the spaceship will take less time than on Earth, which will lead to the brother in the spaceship returning younger than the brother left on Earth. For example, suppose the journey is to the star Epsilon in Eridanus, which is about 10 light years away from the solar system, and the speed of the spacecraft is 80% of the speed of light, that is to say 240,000 kilometers per second. According to the twin left on Earth, the round trip time as measured on Earth is T naught equals to 2 times L naught divided by V equals to 2 times 10 divided by 0.8 equals to 25 years. So the distance between Earth and the star Epsilon is 10 light years, and the twin brother that is on the spaceship does it twice, back and forth. So in total, it does the distance of 20 light years, and it does it in the speed of 80% of the speed of light, that is to say 240,000 kilometers per second. So total way that the twin brother in the spaceship does divided by the speed will give us the total time that it will take him to do all the journey. So the total time is 25 years. Yes, so this is according to the twin, the brother that stays on Earth. So actually that is the time that is passed on Earth. On Earth, the time that is passed is 25 years. According to the Lorentz transformation, the time measured by the twin in the spacecraft is T spacecraft equals to T naught times root of 1 minus V squared divided by C squared equals to 25 times root of 1 minus 0.8 squared equals in total to 15 years. So we see that the time that is passed on the spacecraft is less in 10 years than the time that is passed on Earth. And that is due to time dilation on the spaceship. Because of the fact that the twin brother that is in the spaceship travels at very high speed, then the rate of time flow in the spaceship will be slower than the time flow on Earth. This phenomenon is called time dilation or time lengthening. So because the rate of time flow in the spaceship is less than the rate of time flow on Earth, so the total time that will pass on the spaceship will be less than the total time that passed on Earth. And that phenomenon is called time dilation or time lengthening. That is, of course, according to special relativity. Okay. According to the twin in the spacecraft, he is at rest, while the Earth on which his twin brother is and the star Epsilon in Eridanus are moving across it at a speed of 80% of the speed of light. As a result, the distance between them shrinks according to the Lorentz transformation, so the distance it must travel is L spacecraft equals to L naught times root of 1 minus v squared divided by c squared equals to 10 times root of 1 minus 0.8 squared equals to 6 light years. So, as I've already said, the distance between Earth to the star Epsilon is 10 light years. L naught is 10 light years, but because when someone or something travels at very high speed towards you, there will be a contraction of distance between you and the object that travels at very high speed, according to special relativity. So, according to the brother in the spaceship, he is at rest, and the star Epsilon is moving towards him at very high speed. And in this situation, there will be a contraction of distance between the brother that is on the spaceship and the star Epsilon. And the distance will be contracted from 10 light years to 6 light years only. And this phenomenon occurs according to special relativity. So the distance contracted from 10 light years to 6 light years only, because the star Epsilon is moving towards the brother in the spaceship at very high speed. Okay, so actually the twin brother on the spaceship will have to travel 6 light years in every direction. So in total it will have to travel, 12 light years, and the total time that it will take him to do it is T spacecraft equals to 2 times L spacecraft divided by V equals to 2 times 6 divided by 0.8 equals to 15 years. So, because it travels in total 12 light years in the speed of 80% of the speed of light, the total time that it will take him to do it is only 15 years instead of 25 years that is passed on Earth. In his spaceship it will pass only 15 years during all the journey. This phenomenon is called contraction of distance. Okay, so therefore the two twins effectively agree that the twin in the spaceship will be younger when they meet again. In terms of the twin that remains on Earth due to the effect of time lengthening, as I already explained, and in terms of his traveling twin due to contraction of distance. Yes, I explained that the distance is contracted from 10 light years to 6 light years only, and the total journey will take him only 15 years. Okay, thank you very much.